Hey everyone, this is Ryan Steva from the homesteadconsultant.com. Today I'm going to be going over my custom mobile power unit, sometimes also called a solar generator. I built this one for a specific purpose or for a certain reason because there's a lot of components and parts and things that I couldn't get in a pre-built system. So I'm going to cover quite a few things in this video. I'm going to cover why I chose to do this. What are the pros and cons of building your own as to buying something off the shelf? What are the parts you'll need and how to put them all together? So stick with me. We're going to cover all of that in one video. But to start with, I'm going to give my building parameters and then the pros and cons of why I built my own custom solar generator as opposed to buying something off the shelf. So first of all, my parameters were that I needed readily available parts. I wanted to be able to order parts online or point people to parts that they could order. If any of those parts go bad, you can order a new one and replace it. So for example, I've got a independent solar charge controller. This is a 60 amp MPPT charge controller by Time that has a lot of parameters that I wanted that I can't normally get. And it's an individual part. So if for some reason it ever went bad, I would be able to take it out and replace it and maybe even get warranty on it. So depending on your use case and your need, having all these parts separate really gives you the ability to replace parts if they go bad. Additionally, I wanted to have a really nice balance of quality and value. Using these Time parts, I've got a high quality MPPT charge controller. I've got a Time 1000 watt sine wave inverter, and then a 100 amp hour 12 volt Time LifePo 4 battery, all enclosed in this system. And those I feel like are a really good balance of quality and value. I also wanted ease of assembly, so this container and the parts are all very easy to put together, very simple to understand. So this is the biggest reason I built my own, is that I wanted something that had good solar input. The vast majority of systems have solar input that is well below what the rated output of the unit is. If I want this thing to work well and to actually continue to be usable, I want to have a balanced input versus output. Most of these systems, your solar input is generally limited to right around 400, and your output is oftentimes 2,500 watts. If you put those together, you start to realize that sure, you could plug a lot of stuff into it, but for a very short period of time. So I feel like it's really deceptive and not very useful if you don't have a good solar input that is close to what your rated power output for the system is. So in this case, I've got 740-ish watts of input to the battery into the system and 1,000 watts of output. So imagine running a refrigerator. It might be anywhere from 700 to 1,200 watts startup, and then generally it's going to be about 70 to 100 watts running, which this inverter can do easily. It has a 2,000 watt surge, so it can handle that 1,200 watts of startup for most devices in your home, and then the 100, 200 watt, 300 watt running. So you can run your refrigerator, a freezer, some lights, things like that, all off of the system, while being able to charge it faster than those items would discharge it. So that was one of my biggest hangups with the pre-made systems, is they have low solar input, high output, and they take oftentimes special proprietary solar panels that are very expensive and don't work very well. So I wanted to bypass all of that, and I was able to do that with this system. And then finally, on my building parameters, I wanted Bluetooth. I wanted some type of monitoring system that was simple and worked well, and this charge controller has Bluetooth monitoring. So as far as the pros, I'm able to choose whatever parts that I want to most fit my situation and to make sure that they're readily available to be easily swapped. Another big pro is that you can replace parts as you need to because they're individual parts as opposed to an entire collected system. Much better solar input is an option when you build your own system. You can use higher quality parts. In my case, I feel like these individual lead time parts with the charge controller, the inverter, and the battery are actually much higher quality than what I would get in a pre-built system. This is an awesome learning experience. So whether you're doing it yourself or inviting your kids or somebody else to do it with you, another reason is that I can customize it to what I want and need. So I can get higher quality components, or I could get lower quality components at a really good price, assuming I'm okay to take on the risk of the lower quality component. These systems can be really easy to integrate with existing systems that you have. I could plug it into an RV 12-volt system. I could have a plug on the back that would allow me to do that. I can run anything that would run on a car or RV system rated at 12 volts. And I can use it for projects like lighting my shop, running my tools, charging my power tools, things like that while it's sitting here. And then it should be all topped off from the solar panels that I've got on top of my shop here to be able to take and just go camping or boating or out for the day where I'm going to need power on a remote location. I can disconnect this and take this with me. And then finally, as a pro, I'm able to use standardized connectors. So I've told you all the benefits, all the pros of this system, as well as my build parameters. So here are some of the cons of this system. It's going to take you more work and time. This system's going to be less polished than something you buy off the shelf. Another con is you're going to have limited customer support. You will have customer support for the individual devices, which is, again, part of why I picked out Lead Time. They seem to have very good customer support as well as warranties on their equipment. So that's a big part of why I went with this. But you're not going to have support as a whole for the unit. You're going to have support only for individual parts and pieces that you've put into it. Another con is that you have the potential for wiring or configuration errors. So as you're putting it together, if you wire something backwards and let the magic smoke out of one of the devices, you've damaged it or destroyed it, and that's kind of on you because you did it wrong. The final con that I see is this is not going to be UL listed. It's not going to have any certifications, any warranties, any guarantees because you're building it yourself. So here's the list of parts that you're going to need to put this thing together. The primary parts, like I said, I've gone with Lead Time as my provider for these primary components to the system. The primary parts are going to be the inverter. In my case, I picked a 1000 watt sine wave inverter. A sine wave inverter is really important for the system. You want to make sure that that's what it is because standard old school inverters or square wave inverters can do damage to equipment. And sine wave inverters are readily available. I would just go with that. Don't even bother looking at the cheap square wave inverters. Just go with the sine wave. It's going to save you a lot of potential damage to equipment and headaches as well. The second item is the charge controller. Now, I've already said quite a bit about this charge controller, but it being a 60 amp MPPT is really important to me. I want to make sure it's an MPPT. I want to make sure it's high enough amperage to charge my battery close to as quickly as I can discharge it with my inverter. And I want to make sure it's a high quality unit. This specific unit has a great passive heat sink. It's really, really well built. It has lots of options. And then finally, I've got a 100 amp hour LiFePO4 battery, a lithium iron phosphate battery. And everything that's in these batteries is really well made and been really well tested by a lot of other YouTubers. And it's worth going and looking at just for your own peace of mind before you start using the components that I'm recommending. All right, so those were the three components, the three main components that are absolute musts. There's some additional components that were needed to finish this build. So I'm gonna go through just a quick list of most of those. I will have links for all the different components that I'm using here in the show notes or in the video notes. But the Lead Time products are going to be not just these products, but any products that you order from them. You can get a discount using my promo code. So THC6 is my promo code. So anything you order from Lead Time, you will get an additional 5% off. So the additional parts that you'll need that I'll have links for you are solar input connectors, wiring. So you're going to need solar wiring from your solar panels to your unit. And then you're also going to need the higher amperage battery and inverter charge controller wiring. You're going to need DC breakers or fuses. You'll also need a cooling fan and a power strip. So the last thing I wanted to cover is use cases. Now, it's probably pretty apparent that this could be used for an emergency off-grid type situation where I can plug things in. I can plug in my freezer, my refrigerator, some lights for the house, maybe a fan for when I'm sleeping. All of those things can be plugged in to this unit and run just fine, especially if you have a good solar input or a few panels that you can put out to keep things charged up during the day. Another potential use is off-grid for hunting, fishing, small cabins, bug out locations, things like that. You can pack this with you and go to your location, and it's easy to carry, easy to move, easy to plug into solar. Another potential use for this is when you're traveling. So you can put it in your vehicle and have AC options for connecting devices or charging other things, or maybe a remote work site. If you like tailgating, you know, sports ball, go team. Great option for that as well. Remote building sites, RV, van life, all of those are going to be places where you could use one of these systems. So here is a closer look at the unit. As I was talking about, you can close it up like this. Gets nice and compact. You can also, and those will lock. I just have only one hand. You can also slide this in, so that will fit really nicely into your vehicle. As I said before, I've got MC4 connectors right here, so it's easy to plug in solar panels. Any type of solar panel pretty much should be able to plug into it. And then you can open this back up. Inside here, I've got the charge controller, which I've already talked about, all of my various use cases and the reason I picked out this charge controller. You can also see the breakers that I'm using here, these DC breakers. This is my solar panel breaker. So my wires from here run up, over, and into this breaker. So I can turn my solar off, and you'll see the solar charging disappeared. If I turn that back on, you can see the panels have turned back on. So it's sensing that they're there. Then the MPPT has to take a minute to go through and figure out what the voltage is that it can best use from those panels. And then it's going to send that to the battery and charge things up. So that's my breaker for that. This breaker actually controls the battery, the connection between the battery and the inverter and charge controller. Then in here, I've got the power strip. I picked an Anchor. I like Anchor a lot for these types of things. So it's not only a nice thin power strip that fits in here and things can plug in easily with the space that I have, but it's also got two USB-A ports and two USB-C ports. And those ports have high output or fast charge options on them. So this system can not only run AC items, but it can also charge your phones or anything else that's going to be USB chargeable from that. So before I get started putting things into this, what I want to make sure to do is have my holes pre-drilled so that as I'm drilling through, I don't hit things like my battery or other components. So I want my box to be empty. And what I'm going to do then is find the places that I need to drill holes and drill them. Simple enough, I suppose. Back here, you can see I've already drilled a hole for the fan, but I'm actually going to make that quite a bit bigger. I've got a 4.5-inch fan to fit in this space. So I'm going to drill a hole to match that. So in this case, what I'm going to do is the hole should basically butt up against either side. So I have a 4.5-inch hole saw on my drill here. I'm going to turn the speed down to low so I don't do damage to the box as I'm drilling. And I'm going to drill out that hole. It's going to be about halfway up between here and here on the case. Now I'm going to make a hole on the other side of the case. So one side is going to be just a vent to pull air in. The other side is going to have the fan. I have the two holes in. You can see straight through the case at the moment. But the components are actually going to block that, and I'm going to make a specific channel so that as the air goes through, it cools what I need it to. So I've got fins on this that I want to be cooled, and I want to make sure that the fans on this are pushing air the correct direction, so everything's moving air the same way through this unit. Now that I'm done with that, I'm actually going to dump this out, get rid of all the debris from it. So this end with the wheels on it is going to be our fan. This is the 4.5-inch computer fan, 12 volt DC. I've modified it just a little bit right here. Got the ends there. These ends will actually be going into the charge controller so that when the charge controller is on and working, it's pulling air through the system. Now, what I've already done on the back here is I've taken this, held it right up against the hole or the vent that I want it to go on, and I've made marks for where the screws need to go. And this is just me being kind of lazy. You could probably find a better way to secure or fasten them, but I found that these deck screws, these are 1 5/8" deck screws, work nicely. They fit nice and snug in the connections for these computer fans, this specific computer fan. And it allows me to just screw through the backside into the fan and hold it in place, which allows me to install it or disconnect it easily if I want to. So what I have here is window screen. It's a nylon window screen. I'm going to cut this screen to match my fan so that when I put the fan in, I'm going to block bugs from being able to go in and through into my system here. So there it is. I've cut it just a little bit larger than my fan to make sure that when I put screws through that they'll fit in and I won't have issues with it getting a little bit off. So you can see I now have this 4.5-inch computer fan, 12 volt computer fan installed in into this vent. So I've drilled the 2 vent holes. I also need a hole for the solar wire to go through. And I've already actually drilled that here because I was doing some testing prior to making the video. So this hole is just an 1.5 inch hole. Its purpose is to roughly let the solar connections go through. And we're using a plate like this, a weatherproof plate to go through. And I'll secure this plate here. And then these solar connections are going to be what we're going to use to connect the solar panels from the exterior. This hole also needs to be about 1 inch down from the lip here. So about 1 inch down is about where you want to put that hole. And again, I want to install this before I'm putting anything else in because I'm using screws and drill bits that I don't want to catch any vital electronics. So to connect this to the container, I'm using these 1/4 inch lath screws. So they've got a nice base to push on the plastic so they don't crack things. They're not tapered, so you're not going to push the plastic apart, and they're really nice and short. All right, so our solar wires are in. That's what we need to do for now. I'm going to start putting the major components in with some of the wiring and explain how that's going to work. So the first component to go inside is going to be the battery. One of the really cool things, other than just general functionality, high amp hour rating, and being able to drain these down to 80–90% for LiFePO 4s, is that they're not like lead acids where it matters if you turn them on their side. And so I can turn this one on its side to make everything fit properly, which is exactly what I'm going to do. You can see our leads here. The negative lead needs to go towards the wheels, and the positive lead needs to go towards the handle. And this top is going to set facing that way. I'm going to attach a few leads. This is going to be the most kind of tenuous part where you need to be really careful about how you're attaching leads and what they touch as you're setting things in, because this battery doesn't have an off switch. It does have a BMS, or a battery management system, so it will shut off. If you were to touch the 2 leads together, it will shut itself off, but you have the risk of doing damage or causing arcs or fires. So just be very careful as you're putting the leads on this and putting this part together. So I've got the positive lead here because I was already putting this together to make sure everything fit properly. I've got some cuts, but I'll show you how this all goes together. But this cable again will be in the link in the description. Again, I just want to really stress that if these terminal connectors are connected, that if they touch, you will dead short the battery. So this is an area where you have to use pretty extreme caution. So a couple of notes as to what I'm using here. First of all, these are 2-gauge wires, and I want to use a nice high quality conductor. That is, in this case, I'm using a direct or straight copper braided conductor. And then this is a 13-inch wrench. And so that you want to make sure that these are nice and snug, and that they're not going to that they're not ever going to come loose, so that we have a really good mechanical electrical connection. Additionally, you see me touching these leads by hand. At 12 volts, that's not going to hurt me, but as you get higher voltage batteries, never do that. You may occasionally see me touch the positive or negative leads on the battery with a 20 volt or a 12 volt. I don't need to be worried about that. The higher the voltage gets, the lower the resistance through the body, and actually starts becoming dangerous. So with the 12 volt, I'm pretty safe personally touching it. So here's where the battery goes in, and this is where I have to be especially careful to keep this lead away from the positive lead or terminal. So as I set this in, one of the things that I'm doing is keeping away from this wheel. The battery needs to be on the back side of this wheel well. And so I've allowed it to be on the back side of that wheel, and then pushed as far as I can against the side here. So now that I've done that, I want to secure this wire just by bending it and keeping it out of the way, so that it never touches the positive lead as I'm working. So now that we have the battery done, or in place, at least temporarily, we need to put the inverter in with the face of the inverter facing forwards toward the fan. Now, one of the things that I noticed is that my plug, which I'm going to use for the power strip, doesn't like to plug on once the inverter is in place. It's really hard to get to, and it's a weird angle. So I'm actually going to install that right now, a little bit out of order from how I would normally do this in the video. But I just want to get this in place so that when I want to turn the inverter on, this will already be in place and not difficult. So now I'm going to take the inverter and slide it in next to the battery, and it's going to fit really nice and snug. And the inverter should fit basically all the way against the back, with these wires being basically pushed against the back. Don't want to damage the wires or the connections, but you want to snug it up against the back there. So the inverter and battery, when you lift this, can actually slide back and forth in this system. So what I'm going to do is I'm going to put a piece of wood in there. This is going to serve multiple purposes. And I've put a little lip on the bottom here. I used a quarter round. You could use other things. It doesn't really matter. 1x1 strip. And so the width of this is going to be 12.5 inches in total. And that fits perfectly inside this box, which is part of why I'm promoting this specific box. And then this lip is going to keep the battery and inverter from sliding. And then I cut it about 1.5 inches short because I want the inverter to touch this so it doesn't slide forward, but I want access to the button, the on-off button on the inverter. We're not going to use that button much, but I want access to it if I need it. So I'm going to slide that in over top and push the battery and the inverter to the back of the unit. So I've taken this piece, I've set it in, I've slid it and pushed it back towards the back side of the container here. Now I'm going to fasten this piece of wood in place. So it's going to serve two purposes. One, it's going to hold my inverter and battery in place so they don't slide around. And two, I'm going to put my charge controller and as well as breakers on top of these. So my charge controller is going here. I'm actually going to put another board back here, and my breakers are going to go on top of that board. So now I'm going to use lath screws again. These are 1.25 inches, but again, you can see the head is flat. So when it goes in, it's not going to damage my the plastic here on the side of the unit. Now be very careful when you're doing this. Make very careful measurements so you don't end up puncturing your battery. So here's my second 12.5 inch 1x6. So these are 1x6s. Again, I want to be very careful with my leads here from my battery that they don't end up touching. And so this board is actually going to help me a bit in that, because now it's going to be a break between the positive and negative lead, so that when I put my breakers in, these will actually be separated and make things quite a bit safer. Now, the next thing to note here is that when I put this board in, I want to have my positive lead from my battery coming up the back side. You're going to have a little bit of a gap here because of the ribbing. And then I want to have my negative lead coming up the front side of this board over here. And then on the rib over here, I want my inverter connections coming up. So now I'm going to take 4 more of the lath screws, 2 on each side of the board here, to hold that one in place. Again, be very careful not to puncture your battery, so just take careful measurements. So here is an overview of how this looks. As I said, we've got battery lead here, battery lead there. So the positive battery lead comes up through that, through the rib there, and the leads for the inverter come through the rib there. And then the negative battery lead comes through this open rib here. These are connected. Here I went through and there's just a little bit of a gap. You can see that over here as well. And I just didn't tighten it down. The point is to keep the board from moving up and down. So it doesn't have to be overly tight here. And that board then keeps the battery and inverter from shifting forward or backward. And then this board is going to be the mounting system for the charge controller, which is going to go in here. And then we will have the breakers. Still got to figure out exactly how they set, but the breakers are going to go in here and allow us to be able to turn the system on and off as necessary. So now I've got these two pieces in. Again, this is important. This negative lead coming from the battery is going to go against this back piece. And I've got one more. So I've got 3 1x6s. I'm going to slide this in such a way that this back battery lead just fits in that space. And I want it on this side. So when I put these leads into the breaker, they're going to fit nicely. Now, the last thing I need to do is just make a couple of checks. So I'm going to put the charge controller in here. The charge controller needs to be dead center for these to close properly. And I'm carefully tucking these wires because they're not secured yet, and we've got the live battery wires. So this is kind of the tenuous part that I'm a little concerned about. So I'm trying to be really careful as I do this. So the charge controller needs to sit an equal distance from either side. And then when you close this, basically you can pull this all the way closed and then push the charge controller until it just nudges the bottom of this, because the depth of this side is greater than the depth of this side, meaning this side can slide right over the charge controller. This side cannot, but I want as much room back here for the wiring as I can get. So basically, again, equal distance here, slide this closed, and then push this until it just bumps this. Push this all the way closed. And then the charge controller is going to be in the perfect spot for how you need to mount it. Now that I've got my charge controller in place, I'm going to make an outline on it. So now that I've got my charge controller marked out where I'm going to put things, I'm actually going to start with cable management and breakers. These breakers come with something called DINs. That's this type of mounting hardware. So you put the mounting hardware wherever it is that you want to install the breakers, and then you've got these tabs, and it sits down on the breakers. You put the tabs down like that, and the breaker is held in place. 2 breakers. One is for the battery, one is for the solar input. I wanted to make these breakers slightly above what the rated amperage was for different things, and so that if we had a overamp instance, basically it would shut off. These would trip appropriately, but they wouldn't trip for the actual use case that we're using here. So I needed to make sure that these breakers were not for the same amperage or less. So I just basically bumped them up a little bit from the amperage that each of these things is rated for. In this case, these are specifically DC breakers. You need DC breakers. You cannot use AC breakers or alternating current breakers. You need direct current breakers. These are inexpensive. They're in the link in the description. They are up to 500 volts. And then down to 12 volts. So they'll work for our rated voltage for everything. I've got one that's an 80 amp breaker and one that is a 100 amp breaker. The 80 amp breaker is going to be for my solar panels, and the 100 amp breaker is going to be for the battery. So a couple of things to note. Again, as I'm drilling these DINs in, or the mounting systems, I want to be very careful to only use screws that are not going to go through that 1x material I have. So I have these very small lath screws that will hold those DINs really nicely, but they're nowhere near long enough to go through the 1-inch board that's there holding everything else in place. Now at this point, for that specific location, I'm just putting it in the middle of the wood across the back there, outside of my lines for my charge controller. So right there, you can see a mark for C80A. So that's 80 amps. This is my breaker for my solar. Now these breakers are bi-directional. They really don't care where you put, whether the power is going one way or the other. It doesn't matter as long as above the amperage that's supposed to pass through here is passing through, it shuts off. So you don't really have to worry about directionality of the wiring. I'm taking the negative lead of the solar. So we've got the solar lead right here, and this is the negative lead, and I'm going to put that into the breaker here and securely clamp that down. Now I want to make sure that that is very secure. It's not going anywhere. And then I'm going to take the positive lead from the solar. So that's this one. I'm going to measure where I want it to sit on the breaker, and I'm going to cut it at that length. Now I've temporarily taken the breaker off of the DIN mounting system just so that I can make sure that I'm getting proper connection with my leads here, and that they're seated all the way in. And then I'll put this breaker back in place on the DIN. Now that I've got it in, I can actually pull these wires back out just a little bit to give a tiny bit of slack, because I want these wires to have a little bit of slack and flexibility. The next part is I'm going to take some more solar wire and run it from here around to the front, and I'm going to leave a little bit extra attached. So now I've got a section of positive solar lead, and I've got my a piece stripped off here. You'll see this looks kind of silver. It's tinned copper. You want to make sure you're using copper and not aluminum for all of these connections. So again, once that's in and tight, I want to pull on it and just make sure it can't move around at all. And I've left a little bit of extra so that once I get the charge controller in, I'll have flexibility as to how I install that. And then just leave this lead so that I can connect everything in a little bit here. So I've now got my solar input DIN and breaker installed, so I can turn those on and off. And I'm about to put my battery breaker in. Now, one thing I want to do is keep the orientation of these the same. So pulling back is on, pushing forward is off. I don't want to turn them because that would basically, it would just mess with my brain. I want to know which was on and which was off. I can label it, but having it be the same to turn them on and off the same direction is nice. So I'm going to keep these oriented the same. And this one's going to go on the end over here. And I'll run the positive in and the negative in. So I've cut and stripped both leads for the battery here. Now I'm going to carefully, and I did that very carefully. So as I installed these, I made sure that they didn't touch as they're being installed. So now I'm going to kind of bend these wires back, get everything in place, and slide this breaker over on the DIN. So here's the system so far. I'm about to put the charge controller in, but this is how things are laid out. We've got the solar input wires here, and those run over to this breaker. That's on, that's off. And then these solar wires are eventually going to go into here once this is mounted. We've also got the breaker over here for the batteries, or for the battery. It's a 100 amp DC breaker, 500 volt DC breaker, and it's currently off. If I flip it this way, it's on, meaning these are live. I'm going to flip that off for the rest of the installation until I'm ready to test it. But that's the current setup. So these two breakers are on their DINs held in place, and now I need to wire in the inverter and the charge controller to the battery. So as I do this, I'm going to make sure that this is turned off. Now, this is one spot where I may get some naysayers, but I don't think this is really a major problem, especially because of the amperage that I'm running through here. I'm going to put these two braided tinned copper wires together. They're actually the same wire as the wire from the inverter that was longer than I needed it to be. So I cut it, and I'm going to put these two together under one lug. And then this is going to feed to the charge controller. So the reason that I'm doing this is I want to be able to turn a breaker off to the battery, which is where the high amperage would be able to come from. I want to be able to turn that amperage or power off both to the inverter and to the charge controller at the same time. So that's why I'm running these leads together. Again, I'll probably get some hate in the comments for this, but with braided copper wire and with the type of connectors that these breakers have, it really compresses those together and makes a nice connection. So probably the best way to do this would be a good crimp tool. In my case, I don't have one, and this appears to be holding really, really firmly and not going anywhere. It did take a little bit of effort to get it in there carefully, but now that it is, it should be nice and firm and snug. And I've gone back several times and just retested and tightened as tightly as I need to. And I may do that again after these have been used for a little while, just in case the heat or changing temperatures or weather or whatever allows me to tighten these up more. So now I have my charge controller in place. And before I put these cables to it, I do want to check and make sure that I've placed it properly so that I can close both lids. Yep, they close perfectly, so no issues there. So now I'm going to install my solar input wires from the breaker over to the charge controller. So I'm going to measure each of these. I'll leave a little bit of extra just in case I need to do any manipulation later. But I'll get my lengths, I'll strip this, and I'll install those. Now, the last part of the system that I need to tie in is the fan that we initially installed. I need to make a little adapter for this. Depending on the fan you get, you could actually, the length might be long enough, but in this case I need a small adapter. So the fans come with a little adapter, and on the end is the 12 volt adapter for a computer. I just cut that off, strip these wires back, and the wires, the way you're going to want to wire this in is the wire with the kind of striped white section, or kind of gray, and black is going to be your positive, and the all black wire is going to be your negative. So I'm going to lead these along the side. And so that gray striped one is going to go in the positive of the load. Now I'm installing the wire that is entirely black into the negative terminal on the load. All right, this system should be ready to go. I've used red wire for the entire thing, everything that's going to be the positive side, and black wire for everything that's going to be the negative side. That makes it really easy for me to go through and double check my work, make sure that everything looks good before I start it up. I can also go through with a voltmeter and start to take measurements to make sure that everything is correct and that there's no shorts. I've gone through and done that. That's a little more complex, so I'm not going to take the time to show in this video how that works, but we should be good to turn this on. Let's see how it goes. All right, so the charge controller has gone through its initial phase, and it is showing 13.3 volts, which is going to be appropriate. This battery has been charged, but I've also used it some, so it's already discharged. But it's showing that it's connected only to the battery currently, and that the voltage is correct. And now I can go and hook up to a solar panel if I want to. Currently, the solar connection is turned off, but even if I turn it on, it's not going to do anything right now because there's nothing connected to it. I'm going to leave this off until I hook the solar panels up. Now, another point of contention that people may have with the way that I've set this up is that I'm using these breakers effectively as switches. There's a couple arguments I have there. One, it's going to take a lot of times of flipping these on and off to cause a problem, especially if you don't have a major load on the battery side or pulling from the battery when you flip them off, which you shouldn't. You should have your whatever is connected to your inverter turned off, so there really should be almost no load. So turning this off really should be able to be done repetitively for a very long time before that breaker is damaged. But the argument is breakers aren't switches, which is true, especially in DC. You can do damage to the breaker as you flip it on and off periodically or over and over again. In this case, like I said, I'm not especially worried about it. But the other thing is these breakers are $9. If you damage one after doing this a few hundred times or many hundred times, just buy a new one and put it in. You assembled the entire thing yourself, so you know how to. So for $8 replacement, I'm not concerned about it. To put in a full switch for both of these along with the breaker or a fuse just became more complex and more wiring. So this really keeps the wiring extremely simple and keeps it from getting cluttered. So a couple of things to keep in mind now that it's on is that as the air blows through, part of why I put things in such a tight manner is so that the air actually is going to be forced to go through the fins on the charge controller. And then as we have the inverter on, the inverter, if it gets warm enough, it's going to turn its fans on and blow them this way as well. So everything is going to move through to this side. And so if this heats up, all of that air is going to end up that way. The next part of this build is that we have the inverter that's kind of difficult to get to. It doesn't have any airflow restrictions because we left the two ends open, but we really can't get to the power source very easly. So what I've done is I've put in this power strip, which is by Anchor. I'll have a link in the description, but it gives you four places where you can plug in, which should be plenty for anything you want to run. It should more than adequately carry 1,000 watts, which is what the inverter is rated for. And it has two USB-C at fast charge USB-C and two USB-A fast charge ports. So now we can charge a whole bunch of USB devices off of this system, as well as plug in the devices that we want to use wherever we're at. So we've got our AC connection and we've got fast charge USB connect, 4 of them, so that whatever we want to charge and use, we can. And now for your phone or your other devices that are USB that you want to charge, now you can basically just set them in this box. Let me give you an example. I've got an Anchor battery bank, and I can plug this in here. Now it's charging at as high a rate as it will allow, because those are modern USBs that will do that. And I can leave that sit in there, close everything up, and be good. So here is an interior close-up of all the different components. We've got our solar line coming in and our breaker, which is currently turned off. Those come around and feed into our solar input. These are the lines from the battery that go to this breaker, and then we've got a line there and a line there that go down to the inverter, which the inverter is down here. That inverter is connected to a power strip that sits up here and allows me to plug things in up here. And then we have the fan that is plugged into the load connectors on the charge controller. So now that my system is completed, I'm going to go ahead and make a extension for my solar panels so that I can actually use this on with the panels. So fun fact, the phone that this is being filmed on actually was about to die and was up in a spot where I couldn't really get power to it. And so it's currently plugged in on the workbench, connected to this system, which is totally disconnected from everything. I don't even have solar to it. It's just the battery running the inverter, running the power strip, which is then charging the phone. So pretty cool that I'm able to do that. Of course, I don't have to do that. I've got grid power right next to me, but I thought that it was pretty neat. So anyways, that's how that's currently running. And right now, I'm just putting together these MC4 connectors to connect my system to some solar panels outside. So what I just did is I crimped the conductor on, and then that conductor has barbs, allows me to push this this outside fitting on, and then connect the connection here. So once I tighten all that down, so this should be waterproof. This entire thing should be waterproof. Of course, the case that this comes in is not going to be waterproof. I would not try to leave it out in the rain or anything else. But these MC4 connections will be waterproof. So I have now connected my solar panels on top of my shipping container, and those solar panels connect to this breaker. And you can see there's nothing coming into the system right now. We're using power, but not creating power. So I'm going to flip that, and it should show me, yep, there I've got a solar panel. It takes a few seconds for it to figure out, but then it starts charging. So the MPPT controller basically has to figure out what it needs to do with the power that's coming in, what the voltage and wattage is, to be able to use it to then charge the battery. So now I've got solar charging my battery, and then the battery running the fan here, as well as the inverter below. The inverter running the power strip here, and the power strip charging up my Anchor battery pack. So it's all now working correctly, and you can see the whole system is in this little box and ready to go to wherever I want to. It's reasonably light to lift up. It's very easy to pull around with the large wheels and the handle.